Greetings from Adiman College of Engineering. This is Uma, Assistant Professor, Department of Electronics and Communication Engineering. I welcome you for this presentation on overview of ARM and Cortex M3 processor. These are the contents we are going to cover in this presentation. ARM Cortex M processors overview, Thumb 2 instruction set architecture, Cortex M3 basics, in that registers, stack pointer, link register, program counter, special registers, operation modes we will be studying, and then exceptions and interrupts which are caused in the processors. For that, we will be studying about vector tables, state memory operations, reset sequence. First of all, what is ARM? ARM is formally an acronym for Advanced Risk Machines, and originally it was Acon RISC machine, which is a family of RISC instruction set architectures, which is shortly termed as ISAs for computer processors. ARM Limited develops the ISAs and licenses them to other companies that build physical devices that use the instruction set. It also designs and licenses cores that implement these ISAs. Due to their low cost, low power consumption, and low heat generation, ARM processors are useful for light, portable, battery operated devices including smartphones, laptops, tablet, computers, and embedded systems. However, ARM processors are also used for desktops and servers, including the world's fastest supercomputer Figago from 2020 to 22. With over 230 billion ARM chips produced as of 2022, ARM is the most widely used family of instruction set architectures. With this introduction, just I will go into the processor basics. This is the ARM1 second processor for the BBC Micro, which was developed by ARM Limited. You can check this more about ARM processor using this link. The ARM architecture defines things like the instruction sets, registers, and the memory systems. Vendor can buy either only the architecture license and implement their own code. ARM has three architecture profiles. First is ARM Cortex application profile, which is nothing but A profile. Then Cortex real time profile, R profile. Then Cortex microcontroller profile, which is nothing but M profile. Under M profile, we have ARM V6M, ARM version 7M, ARM version 8M. These architecture profiles are implemented by different cores. Cortex M0, M0 plus M1 implements ARM version 6M profile. Cortex M3, M4, M7 implements ARM version 7M. Cortex M23, M33 implements ARM version 8M profile. The ARM M profile ranges from low performance small size microcontroller, example Cortex M0, to high increasing performance bigger size ones, example Cortex M33. In general, M profile cores are optimized for cost and energy efficiency. These are used in millions and millions of consumer devices. The Arm Cortex M3 and M4 processors are designed by Arm. The Cortex M3 processor was the first Cortex generation of processors released by Arm in 2005. The Cortex M4 processor was released in the year 2010. Cortex M3 and M4 processors use 32-bit architecture. Its internal registers are in the register bank, the data path and the bus interfaces are all 32 bits wide. The instruction set architecture, which is nothing but ISA, in the Cortex M processor is called the Thumb ISA and is based on Thumb 2 technology, which supports a mixture of 16-bit and 32-bit instructions. The Cortex M3 and M4 processors will have three-stage pipeline design, Harvard bus architecture with unified memory space, 32-bit addressing, supporting 4 GB of memory space, on-chip bus interfaces based on ARM AMBA technology. An interrupt controller called NVIC, Nested Vector Interrupt Controller, supporting up to 240 interrupt requests and from 8 to 256 interrupt priority levels dependent on the actual device implementation. Supports various features of operating systems and provides sleep mode support. It also supports an optional MPU, that is memory protection unit. It supports bit data accesses in two specific memory regions using a feature called bit band. The option of being used in single processor or multiprocessor designs. Apart from the features which are listed in slide 9, there are some advanced features for Cortex M4 processor when compared with Cortex M3. So they support wide range of instructions. In Cortex M3, general data processing including hardware divide instructions, memory access instructions supporting 8-bit, 16-bit, 32-bit and 64-bit data, as well as instructions for transferring multiple 32-bit data. Then it supports instructions for bit field processing. It supports multiply, accumulate, that is MAC instructions, and saturate instructions, instructions for branches, conditional branches and functional calls, instructions for system control, OS support, etc. So these are the instructions which are supported by Cortex M3 processors. In addition to this, the Cortex M4 processor will also support for single instruction multiple data SIMD operations, additional fast MAC and multiply instructions, saturating arithmetic instructions, optional floating point instruction, that is single precision. So, both the Cortex M3 and M4 processors are widely used in modern microcontroller products as well as other specialized silicon designs such as systems on chip SoC and application specific standard products ASSP. There are a lot of similarities between the Cortex M3 and Cortex M4 processors. Most of the instructions are available on both processors, and the processors have the same programmer model for NVIC, MPU, etc. However, there are some differences in their internal designs which allow the Cortex M4 processor to deliver higher performance in DSP applications and to support floating point operations. As a result, some of the instructions available on both processors can be executed in a fewer clock cycles on the Cortex M4. So this is the Cortex M4 processor family. As I said before, Cortex M3 and M4 processors are based on ARM version 7 M architecture. Both are high performance processors that are designed for microcontrollers. Because the Cortex M4 processor has SIMD fast math and saturate arithmetic instructions. It can also carry out some of the digital signal processing applications carried out by a separate digital signal processor. The Cortex M0, M0 Plus, and M1 processors are based on ARM v6 M profile, which has a smaller instruction set. Both Cortex M0 and M0 Plus very small size in terms of gate count, with just about 12K gates in the minimum configuration, and are ideal for low cost microcontroller products. The Cortex M0 Plus processors have most state of art low power optimizations and has more available optional features. The Cortex M1 processor is designed specifically for FPGA applications. It has tightly coupled memory TCM features that can be implemented using memories inside the FPGA, and the design allows high clock frequency operations in advanced FPGA. In this slide, you can see the ARM v6M architecture and ARM v7M architecture and the core feature. In ARM v6, we can have ultra low power, low cost microcontrollers for M0 and M0 Plus, whereas M1 is specifically designed for FPGA designs. In ARM v7M architecture, Cortex M3 and M4, the core is 3.32 core mark megahertz, 3.4 core megahertz. It is a processor with rich high performance microcontroller products. Here you can see Here you can see a lot of evolution of Cortex processors from 2003 and future. Again, this is a evolution of ARM processor architecture from ARM architecture version 4, 4T, version 5, 5E, version 6, version 7. So in version 7 we will be having three types of profiles, that is based on microcontrollers, real-time profile, application profile. But there is one important point to be considered, that is ARM does not make microcontrollers, but many microcontrollers will have ARM products. So here you can see a microcontroller might contain multiple ARM IP products. In the middle part, it is designed by microcontroller vendors. So here you can see ARM processor, which is an ARM product. It may be Cortex M profile with various versions. You can see in the infrastructures, the bus components, peripherals, memory controllers, everything will be in infrastructure, SRAM, peripherals, interfaces. So in interfaces we'll have input output libraries, memory libraries, everything. So this whole microcontroller design will be given to the semiconductor industry, for which is given to the semiconductor industry for chip manufacturing. So these are the advantages of ARM Cortex M processor: low power, high performance, energy efficiency, core density. It can handle many interrupts, ease of use, it is C friendly, scalability, it has debug features, it supports many OS, that is operating systems, versatile system features, it provides software portability and reusability. It do have various choices for devices interfaces, tools, operating systems. These are the applications of Arm Cortex M processors. These processors can be used in microcontrollers, automotive applications, data communications, industrial control, consumer product systems on chip, mixed signal designs. So thank you. Thank you.